Are you ready for another network analysis lab? If you haven't seen my previous videos where I go through different labs, I would highly encourage you to take a look at those to gain some valuable hands-on skills. In today's video, I'll be going over another hack the box Sherlock lab called Meerkat. Let's get started. I'll be using a Windows virtual machine with WSL installed, which is Windows subsystem for Linux. This will allow me to run Linux commands on my Windows machine, and if you want to follow along, you can either install WSL or use a Linux-based operating system. The first thing you want to do is head over to Hack the Box and make sure you create an account if you haven't done so already. And then you'll want to head over to the Hack the Box labs, and once you're signed in, head over to Sherlock's on the left, and then what we're looking for is called Meerkat. We can go ahead and search this up, or we can click on Retired. And at the bottom, we see Meerkat. Let's go ahead and click on that. And let's go over the scenario. As a fast-growing startup, Forella has been utilizing a business management platform. Unfortunately, our documentation is scarce and our administrators aren't the most security aware. As our new security provider, we'd like you to have a look at some PCAP and log data we have exported to confirm if we have or have not been compromised. Based on this scenario, we know we are going to be likely dealing with a business management platform. So to begin, let's go ahead and click on this download button and then click on the key icon to copy the password. We'll use the password of hacktheblue to extract the files. Over to our desktop, I'll right click Meerkat, head over to 7-zip and extract to Meerkat. I'll paste in the password. Now we have a directory called Meerkat. So we have a PCAP file and we also have a meerkat-alerts.json. Now go ahead and open up a Linux shell and I'll type in ls. We do see the two files there. I'll just type in file and we have the JSON file with ASCII text and the PCAP-ng capture file. So what we can do is start off with the alerts by typing in cat meerkat-alerts and hit enter. Now there is a lot of data and it is formatted in JSON. Whenever you see data that is formatted in JSON, I want you to be aware that when you scroll all the way up, you'll notice that JSON data is wrapped in a square bracket. We see that here. And then afterwards, there are nested strings as you can see with the curly bracket. To extract the values within Linux, we can use a tool called JQ. I'll clear out the screen. And to use the tool, we simply type in jq.meerkat. Now it says here, the command jq is not found, but it can be installed with sudo apt install jq, which is what I'll use, install jq. Type in my password. Now that that's installed, I'll go ahead and clear out the screen. I'll type in jq.meerkat. And before I hit enter, this dot will instruct jq to read everything under this alerts.json file. And we see all of the data that is formatted in JSON. With JQ, we can also select specific fields to use. So for example, if we take a look at what is available, we have TS, which is timestamp, the source IP, source port, dest IP, dest port. But what I'm interested in is the signature. And this signature currently lives under alert. And in order to select the signature, I'll run the following command. I'll type in JQ, and then I'll type in a dot because I want JQ to select everything. I'll use the square brackets. The square bracket is essentially saying to take each item within the square bracket, aka the array, and then output that. I'll then say dot alert. The dot alert will tell JQ to look inside the alerts field. For example, the dot alert will begin here. So it's saying, okay, dot alert, take a look at this. And then we can select any field after. We're interested in signature, so I'll type in dot signature. And this command will essentially grab the value right here for signature. And signature is nested under alert. Finally, we'll point it over to the meerkat-alerts file and hit enter. Now we have extracted all of the signatures. However, you might notice they are surrounded in quotes. To remove that, we'll just type in -r. The -r flag is going to output the data as raw strings and not JSON, which is what we see here. So I'll press enter and here we go. These are all of the raw strings here. The next thing to do is run a sort and I'll unique it with a -c and sort again. And taking a look at the top signature, we have user agent Python request inbound to web server. And there are 134 events. At the bottom, we also see an attack underscore response possible /etc/password. Now, for those that don't know, this file contains information about the users that exist on the server. So what I'll do is I'll output this and call it signatures.txt. Next, let's check out the source IPs. So I'll run jq.meerkat. And if we scroll up, we did see the source IP field as source underscore IP. So let's do what we did earlier for the alert signatures. So what I'll do is I'll type in a dot with a square bracket, dot source underscore IP. And now if we hit enter, we get our source IPs. However, the output is in JSON format. So let's go ahead and add in the -r flag for raw strings. And we have this output. Now let's do the sort unique-c sort-nr. And looking at the top IP, we have 156.146.62.213. We also have a second external IP, 138.199.59.221. Let's go ahead and put this into a file called source-ips.txt. Now you might ask, is it possible to combine the source IP and the alert signatures? And that's a great question. Yes, you can. To do that, I'll go ahead and clear out the screen. I'll type in JQ. Let's just include the R right here for the raw strings. And I'll put it in quotes. So dot to read everything, square bracket. And I'll add a pipe with a quote, /parenthesis, dot source, IP, close it out. And let's do another one with dot alert, dot signature. Put in a double quote and a single quote. Now you might be like, what the heck does this do? So basically, the .r is going to output the strings, which we already covered. The dot square bracket is saying to grab all of the fields within the square brackets. And the / surrounded by parentheses is telling JQ to grab those field values. And let's point it over to Meerkat-alerts. And you know what? Let's do a sort. Just like that. Hit enter. Let's scroll all the way up here. And we do see our top IP address of 156.146.62.213. And it has the user agent Python request. But if we take a look at the second signature, we do see a possible staging for CVE-2022-25237. And it says web-specific apps, Bonita Soft. So what is Bonita Soft? On Google, I'll just copy the Bonita Soft and hit enter. So this one is a business process management. Hey, so that is the application that we saw from the scenario. Varela has been utilizing a business management platform. That is likely the Bonita one. Now, going back over to our logs, we did see a CVE right here. So 2022-25237. I'll copy that, go back into Google, and let's paste that in. And the link from Rhino Security Labs, we see Bonita Soft Authorization Bypass and RCE. RCE is remote code execution. So taking a quick look at the overview, Bonita Web 2021.2 is affected by an authentication/authorization bypass vulnerability. And this is due to an overly broad filter pattern used in the API authorization filters. So that is always a fun time. Now we do see our vulnerability details, but what I'm most interested in is the proof of concept. And here we go, we have it. So Bonita exploit proof of concept. To run the vulnerable version of Bonita, you can use the Docker repository. And here we see the /etc password. Now, although this is likely just a test command, we did also happen to see the /etc/password signature in our logs. And if we scroll down, we do see it right here. Likely to say that this was successful. Scroll up just a bit here. And we see two values were found that work to accomplish this. Simply appending either a /I18n translation or a semicolon I18n translation to the API URL, which will allow authorization to be bypassed. Yeah, that's never a good thing. But what we can do next is to take a look at Wireshark. So I'll go ahead and just double click this PCAP and open it in Wireshark. Now, if you have never used Wireshark before, I would highly recommend you go and take a look at my other SOC related labs on my channel. First things first, I want to investigate the IP address that we saw in our signatures, or alerts. So we scroll up. The IP of interest is this 1561 because this one has the most activity based on our alerts file. So I'll copy that, head over to Wireshark, and I'll type in ip.adder equals, and let's paste in that IP address. Now, right off the bat, we do see a lot of reset. Reset ACK requests. If we scroll down, look at that. There's just a lot of reset ACKs here. But eventually, we get hit with the first HTTP protocol request. So how about we filter for HTTP? And to do that, we can just right-click the protocol, select Prepare as Filter, and select it. I'll go ahead and hit Enter. And here is all of the HTTP requests from this IP of 156 on packet 2134 that occurred on 2023-01-19 at 15:31:11 UTC time. So I'll go ahead and just right-click this, follow HTTP stream, and let's take a look here. We have our user agent, so it's a Macintosh of some sort. We have the GET request towards Bonita on our host at forella.co.uk on port 8080. And it seems like that's about it. Well, we also get a Bonita portal homepage, but nothing interesting. I'll select the dropdown and rerun the query with the HTTP protocol. And if we scroll down, and on the packet number 2158, we do see our first post request. So let's go ahead and follow that. And this is towards the login service with our user agent of Python request. And we see the username equals install and password as install. So we do see some authentication attempts here. There's also another username of clerk.killick with this random password. I'll click on the dropdown again and filter for HTTP. Let's take a look at the second post request and follow HTTP stream. And that is the same thing. That is the clerk.killick one. So what about the third one, which is this one right here? Follow HTTP stream. And we still get an install, but there's a different user. So what this tells me is that it's not particularly a brute force per se, but it's actually a credential stuffing attack. So if we go over to MITRE ATT&CK, and if we search up brute force, we see that brute force has a total of 4 sub-techniques. So when you click on that, we do see a sub-technique called credential stuffing. And here it says adversaries may use credentials obtained from breach dumps of unrelated accounts to gain access to target accounts through credential overlap. Going back over to our Wireshark, I'll close out that window and let's filter again for our HTTP. And since we know that these post requests are very likely the credential stuffing activity, we'll just scroll down and ignore them for now. Let's see, what else is there? There is a GET request, Bonita/API extension RCE with a command of who am I? Okay, that's not good. And if we take a look at the top, we see a post request here, Bonita/API/page upload, and take a look at that. I18N translation. Now, if we go back over to our proof of concept, but right above it, we see the 2 values were found, which is the I18N translation. So this is definitely not a good day. So I'll go ahead and right click the GET, follow HTTP stream, and let's take a look here. So we see the post request for the install. The server responds back with a 401 status code. And then there's another post request. The username is seb.broom and the password is government. And the status response is 204. So let's search up what status 204 is. And it says the HTTP 204 no content success status response code indicates that a request has succeeded, but that the client doesn't need to navigate away from its current page. So this likely indicates that the user account of seb.broom with the password of government was successful. In other words, our attacker successfully authenticated with this user. At the bottom, we have our page upload with our value of I18N translation. So we have a PK information, RCE API extension.zip. And scrolling down to the bottom, we did see a who am I, so that's why we followed the stream. And right here, we see that who am I was requested. And if this was successful, the server would respond back with who am I? Nice. Okay, that is incredible. So we know for sure that the exploit works. Going back to our Wireshark, let's head back over to our filter of HTTP and let's scroll down to see if there's any other ones. Does not appear to be so. Okay, all right, let's take a look at the second IP address that we saw from our logs. So if we clear out the screen here and cat out the source IPs, we did see a second external IP of 138. So I'll copy that, go into our Wireshark, and you know what? Let's keep the HTTP just for now, and I'll replace the 156 with the 138 IP and go ahead and hit enter. And we do see a post towards the Bonita login service. And on packet 3639, we do see another I18N translation. So there's some remote code execution happening here. We see a GET request of a command that says wget https paste.io. Okay, let's go ahead and follow that. And we do see the install. We see the seb.broom account that's being used with a response code of 204. And at the bottom, we got a request right here towards this domain of paste.io. So I'll copy that. And what I'll do is head over to browserling and let's go ahead and paste that in. So we see that this particular paste performs a curl command and retrieves the content from this URL and then appends it to this file. Let's quickly copy this URL here and I'll paste it in browserling. So this does appear to be an SSH key, and this also performs a sudo service SSH restart. Let's take a quick pause to recap what this script actually does. So this script retrieves an SSH key by performing a curl command towards that URL, and then it appends it over to the .ssh as a persistence mechanism, because anything under the authorized keys is considered to be trusted. Now an attacker with that particular SSH pairing can now SSH into the server without any difficulties. Going back over to our Wireshark, let's take a look at when this actually was executed, because we know that it was obtained via the wget, but we don't know exactly when it was executed. So this particular script was obtained on 15/38/52. We see a command for bash and it ran bx5gcr, and we see that as the script name here. So that means the script ran about 26 seconds later. I'll go ahead and remove our query and let's take a look to see if there's any SSH connections after running the script. We can just simply type in SSH. And after about a minute, we see SSH connections coming from 95.181.232.30. Nice. We should have enough information to start answering some of the questions. But before I jump in, I have an upcoming SOC course that is expected to be released on June 10th if there's no issues. This course will contain over 30 plus hands-on labs and have 5 exclusive SOC projects. If you or someone you know is interested in particularly the security operations domain, this course is designed to help students learn how to ask better questions and investigate network, endpoint, malware, identity, and cloud-related telemetry. Once you purchase it, it is yours for life and updates are free. The price is going to be $499 plus tax USD, and I'll provide all the links in the description. Looking at our questions, we believe our business management platform server has been compromised. Please, can you confirm the name of the application running? Well, that I can. So it is called Bonita Soft. Question number 2. We believe the attacker may have used a subset of a brute force attack category, and that we know as credential stuffing. Does the vulnerability exploited have a CVE assigned, and if so, which one? Yes, it does. If we go over to our site, we have the CVE here, so I'll copy that and I'll paste it over here. Which string was appended to the API URL path to bypass the authorization filter by the attacker's exploit? Back to that site, we saw it was the I18N translation. Now, I'm not sure if I have to copy the semicolon, but let's just try this for now. Oh, please enter with no special characters. Okay. Nice. How many combinations of usernames and passwords were used in a credential stuffing attack? Going over to our Wireshark, let's try this out. So we know that when you enter in credentials, you get a post request. So I'll type in http://request.method == post. And we know that this was all happening on the login service. So just to make sure, I'll follow this HTTP stream, login service, and we see a username. So this is what we want. I'll go ahead and click on the post filter again. And let's just select any one of these. So what I'll do actually is filter specifically for post requests towards the login service. And we can do that a couple ways. We can expand the HTTP transfer protocol, expand the post, and we can just right click this and prepare as filter, or we can filter by the content type, which is the application form URL encoded. But let's try the request URI. I'll click on prepare as filter, selected. I meant to add in and selected, but that's okay. I'll just type in http.request.method equals post. So now we have a total of 118 events, as you can see at the bottom that says displayed. And we can grab the username by expanding the form URL encoded, and we see it right here. So I'll go ahead and expand the form item, and I'll right click the value and select apply as column. Now we see the values. So there's the username and then there's the password. Now what we can do is just sort the value, scroll all the way up, and we can begin counting this. But 118 values, that's quite a bit. What I'll do is I'll Control A to select all of the packets, click on File, and let's save this out. So I'll export specified packets, go over to my desktop, go into my Meerkat, and I'll say users. I'll just leave it as users. Click on Save, and now we can use a tool called TCP dump. Now I'm pretty sure there are other ways to grab usernames, but I thought this would be a pretty fun exercise. So I'll clear out the screen here. And I'll use TCP dump-R to read in the file of users.pcap. And now we see the packets that we selected. What we can do with TCP dump is include a -A, which will then show us the packets in ASCII format. And if we look at the bottom, we see the username equals seb.broom with the password as well. And now what we can use is a pipe and grep to search for the keyword of username. And now we do see a lot of the users. And I'll export this to a file called test.txt. Let's clear out the screen and I'll type in cat test.txt to see if I have the data. And we do. The next thing I'm going to do is use a cut command, use the delimiter of an equal sign, and then I'll select field 1. We do see it is selecting the username, so this looks pretty good. I'll select field 2, and there you go. Now we have the username and the password. What I'll do now is sort it and unique. And taking a look, we have the username and password, but we also have this field called musername and username. So that doesn't look like a proper username because there's no password as well. Whereas the other ones, you do see a and password, but for the username, you don't see an and password. So that's likely not a valid username. So I'll go ahead and just remove that by using grep-v to exclude. And I want to exclude username. And now that should be gone. Beautiful. Let's add this to test1.txt. And let's cat that one out. So I'll clear out the screen, cat test1.txt, and we get this file. Looking at the usernames, we do see a %40. And we also see an ampersand. So that means we'll need to cut -d, and I'll use the %-f1. And the next one we got to do is the ampersand. Do the ampersand -1-f, select 1. And that is our usernames. So let's go ahead and output this to users.txt. And finally, cat out the users.txt pipe with wc-l. This is essentially counting each line. And we get 56 lines. So this means that there are 56 individual users. Now I know this is probably a roundabout way to capture all of the users, but it's a pretty fun exercise. So let's type in 56 and awesome. Which username and password combination was successful? Ooh, that one we know. If we head over to our Wireshark, at the top, we do see a Seb Broom with the password of government. And we know this because the server responded with a 204, whereas the other ones that did fail responded with a 401. So I'll copy the password because this one's a lot more difficult to spell. And the format is user:password. So seb.broom:password. Wrong answer. Oh, that's right. Okay. So it's this right here, but there is a percentage 40. Now you might be scratching your head. What does that mean? Well, it's actually an encoding. So if you go into CyberChef and if you type in %40, so we'll type in decode, and we want to look for the URL decode, which is this one right here. I'll drag that over to the recipe, and we see %40 is essentially an @ symbol. So we can safely say that this is seb.broom@forella.co.uk. So I'll copy that, active box, and then I'll just paste that in here. Change the %40 to the @ symbol. Awesome. If any, which text sharing site that the attacker utilized? We saw this by the attacker using the wget command. So if we scroll down, we should still have it here. And it is right here, https paste.io. Does it want the entire thing? Oh, just paste.io. Okay. Please provide the file name of the public key used by the attacker to gain persistence on our host. The file name of the public key. So the file name of the public key is actually in our browser link, and it's time's up. Okay, so let's refresh that. So our bx5 script goes out and performs a curl command towards this domain. So that means this hffgra4unv is the file name. hffgra4unv. Nice. Can you confirm the file modified by the attacker to gain persistence? That I can. It is the SSH one. So this path right here, /home/ubuntu/.sh/authorized_keys. So I'll go ahead and just type that, home ubuntu.sh authorized_keys. Can you confirm the MITRE technique ID of this type of persistence mechanism? Heading over to MITRE attack, we know it is persistence. So let's look at persistence. There are 20 techniques. Now, instead of searching for each technique, what we can do is just click on the search at the top right and type in SSH. And we see account manipulation. And take a look at this right here, the path of .sh/authorized keys. So I'll expand this, and right here, SSH keys with a sub technique of T1098.004. So I'll copy that and I'll paste it in here. Awesome, we just completed Meerkat. That was a pretty fun lab. And hopefully by following along, you have not only learned something new, but you are also becoming a lot more confident when performing network analysis. And that is it for the video. I hope you found that informative. If you did, let me know by hitting that like button and subscribe if you want to. Remember to stay curious and do things differently.